James Webb Space Telescope, JWST, Pluto is no longer seen as a silent, lifeless world. Instead, it's becoming one of the most mysterious and fascinating bodies in our solar system. The visuals sent back from JWST have challenged nearly everything we believed about Pluto. What was once considered a dull, inactive planet now appears to be hiding something far more complex beneath its icy crust, something that could reshape how we think about the potential for life beyond Earth. At the heart of Pluto's icy secrets lies its most iconic feature, Sputnik Planitia, the giant heart-shaped glacier that has captured the imagination of scientists and space enthusiasts alike. This massive ice plain, made largely of frozen nitrogen, is not just visually striking, it's geologically important. It's so enormous that it affects Pluto's rotation and its gravitational balance, almost as if the planet is weighted on one side. But what lies beneath Sputnik Planitia may be even more remarkable. Beneath its thick frozen shell, scientists believe there could be a liquid ocean, an underground reservoir of water kept from freezing solid by heat generated deep within Pluto. This internal heat likely comes from radioactive materials decaying slowly in the planet's rocky core. Despite being nearly 6 billion kilometers from the Sun, this residual heat may be enough to keep water in a liquid state below the surface, making Pluto not a frozen wasteland but a dynamic and evolving world. This possibility changes everything. If Pluto does have a subsurface ocean, it might also support some form of life. Far from being a barren ice ball, Pluto could host conditions necessary for biology, albeit in a radically different environment than Earth. The idea of liquid water, even in such a distant part of the solar system, opens up profound possibilities. After all, water is the cornerstone of life as we know it, and wherever there's water, the potential for life follows closely behind. Supporting this theory are signs of geological activity. The New Horizons mission in 2015 revealed that Pluto's surface is covered in fault lines, ridges, and tectonic fractures, features typically associated with an active, dynamic world. These are not the scars of a frozen, ancient surface, but indicators that Pluto's interior is still restless, reshaping its icy shell. Even more puzzling is Pluto's gravitational relationship with its largest moon, Charon. Unlike typical planet-moon systems, Pluto and Charon are locked in a binary orbit, with both bodies circling a point in space between them. This gravitational dance causes tides within Pluto's crust, and possibly within its suspected subsurface ocean, generating additional heat and motion. These interactions remain poorly understood, but they may play a critical role in maintaining Pluto's geological, and possibly biological, activity. And what if the ocean isn't just liquid, but alive? Some researchers speculate that Pluto's interior could be home to microbial life adapted to the dark, high-pressure, low-temperature conditions beneath the ice. These life forms, if they exist, would have evolved in isolation, shielded from sunlight, radiation, and extreme cold by thick icy layers. According to physicist Brian Cox, the mere presence of microbial life in such an extreme environment would revolutionize biology and our understanding of where life can exist in the universe. But not all signs point toward peaceful life. The James Webb Space Telescope has detected unusual heat signatures and chemical markers beneath Pluto's surface, patterns that, while still unexplained, resemble those produced by biological processes on Earth. Some scientists have even raised the unsettling possibility that Pluto could host life forms that are not only alien but also dangerous, perhaps completely unlike anything our planet has ever known. What if these organisms thrive in an environment so foreign that they challenge the very definition of life? One theory suggests that Pluto's hidden ocean formed in the aftermath of its violent formation. It's believed that Pluto originated in the early chaos of the solar system, built up from repeated collisions and impacts that generated enough heat to melt internal ice. Over billions of years, that residual heat, fueled by radioactive decay, could have kept part of its interior in a liquid state. If true, then Pluto has been an active world since its birth, formed by fire, encased in ice, and still alive beneath the surface. Adding to its complexity, Pluto has a thin but surprisingly dynamic atmosphere, mostly composed of nitrogen with traces of methane and carbon monoxide. These gases create a reddish haze around the planet, caused by organic molecules known as tholins, which are formed when ultraviolet light from the sun reacts with atmospheric chemicals. Tholins may be key ingredients in the chemistry of life and hint at complex organic processes taking place in this remote world. Pluto's connection with Charon deepens the mystery. Charon's surface shows deep chasms, grooves, and ridges, suggesting tectonic activity in its own past. At its poles, strange red caps have been observed, possibly formed when gases from Pluto escape, drift across space, and freeze on Charon's surface. This eerie relationship between two distant worlds raises a fascinating question. Could Pluto and Charon be influencing each other's geology, chemistry, or even biology? Pluto stands out among the many objects in the Kuiper Belt, a distant region filled with icy remnants from the formation of the solar system. Most Kuiper Belt objects are cold and inert, but Pluto defies that norm. Its moving glaciers, active surface, atmospheric haze, and internal heat make it an outlier, a place of action in a region thought to be asleep. And if Pluto is active, what about other icy bodies beyond Neptune? Could similar oceans and hidden processes be waiting to be discovered on these worlds as well? The James Webb Space Telescope has opened a new chapter in Pluto's story, but it has also left us with more questions than answers. The 2015 New Horizons flyby was just a brief glimpse, an incredible one, but not nearly enough. Future missions will need to do more: orbit Pluto, drill into its icy shell, analyze its atmosphere in greater detail, and explore the mysterious ocean that may lie beneath. Each new discovery could bring us closer to understanding the building blocks of life, the history of the solar system, and our own place within it. One area that remains largely unexplored is the possibility that Pluto has a magnetic field. While we don't yet have direct evidence, some indirect data suggests magnetic activity might exist below the surface. If true, it could help shield Pluto's atmosphere and internal ocean from solar radiation, much like Earth's magnetic field protects us. This invisible force could also explain some of the unusual geological patterns and heat emissions observed across the planet's surface. Pluto's location in the outer solar system also means it is exposed to unique forces. Gravitational tugs from other Kuiper Belt objects and passing stars may help stir its interior, maintaining internal activity that we once thought impossible for such a small and distant world. Ancient impacts and collisions might have also played a role, reshaping Pluto and leaving behind clues still etched into its surface. Once dismissed as a cold, dead rock, Pluto is now a planet of riddles, surprises, and potential. With flowing glaciers, shifting ice, mysterious chemistry, and a possible subsurface ocean, it demands a place among the most fascinating objects in our solar system. It challenges our definitions of what a planet is, what makes a world alive, and where life might arise. So now the question is not just whether Pluto could support life, but what kind of life it might already hold. What secrets are frozen beneath the surface? What forces keep this distant world alive? And what else might be waiting in the twilight of the Kuiper Belt, in places we've barely begun to explore?